Hello, welcome to Oricot, and in this parametric origami crease pattern, I'm going to model a pattern in Grasshopper and change the parameters. As you can see, I can change the shape and produce different crease patterns. And finally, I can fold it. Here I can fold it. Let me just reset this and fold the pattern and see the result. So this tutorial is going to help you to produce different patterns really easily by just changing the parameters. For example, if I go here and turn off the simulation, let's just go and change the number of sides to 3. I'm going to explain these parameters in the tutorial and how we can define that. And it's going to give us new results, and this is great because you can actually produce different results without even thinking about the crease patterns. And you can see that I can produce a new one simply by just changing the different parameters I have defined and used to define the base geometric crease patterns. Okay, let's get started from scratch. But before we get started, if you're new to our channel, consider subscribing because we have weekly tutorials about origami crease patterns on Oricot. And we are also developing a new plugin which you can use different tools to produce really easy, fast, grid-based crease patterns. Okay, before we start the tutorial, let me explain about the base pattern and how we going to make it in Grasshopper. First of all, assume that we have like 360 degrees, okay, in a circle. And if we divide it into 4 parts, it's going to give us like a 90 degrees for each side. Each side for this pattern has a half, so we have to divide that 90 degrees again to 45 degrees, okay? That is going to be the symmetry line, and we just have to focus on this part, okay? And as you can see, let me just go to the blue. We have this point. So we actually have 5 points to define the pattern, and we have to move it on the X line and on this symmetry line. Okay, so I'm going to define these points in Grasshopper and then connect them and then find the mirror of this pattern to get the next part, and then we can make a simple make an array of the complete pattern to produce the final results. Okay, for example, we want to make this pattern in Grasshopper. I'm going to put the bifocals plugin so you can see step by step what I'm doing and then go for the last step. So first of all, if I just double click on the canvas, remember I'm using the display as icon, display draw icons and full names so you can learn it easier. First of all, I want to just use 2 forward slashes. So remember you have to double click, 2 forward slashes and enter to have a panel. And I just want to type 360 degrees. And this is the degree that we want to divide here. So I'm going to go to the math section, and here we can easily have the division to divide that 360 degrees. And I'm going to give it a number slider. So it's going to be like 3 points to maybe like 12-sided pattern. So this is going to be the count. So I'm going to change that to the count and name it as count so we can have the base degrees. Okay, let me just connect a panel again to this so you can see that. And that is like if I give it like 4, it's going to be 90 degrees. Because we have to divide it again by 2, I'm going to change that 360 to 180 so we get exactly the degrees we need here. Okay, so remember that we need that 45 degrees, and let's get to the next part, which is defining these points here, which is actually not really hard. We have to define 2 points and move them in the X direction. So let's just go to the vector section, and I'm going to use this construct point to make a point here. And as you can see, it's going to give an X, Y, Z coordinate, and by default it's like 0, 0, 0, and that is the point. Let's give it a number slider. So I'm going to say, for example, from 1 to 100 with 2 decimals. Remember that if you want to give this number slider from a number to a number, you just have to give it 2 points here. And then if you give that number like 0.2 decimals, the number slider is going to be with 2 decimals. That's the fastest way you can use a number slider. So I'm just going to say 2 decimals. If you want to change it, you have to double click here, change the number of digits, and also the minimum and the maximum. So that was the fastest way you can use that. And let's just name that X1 for the first slider. And this is going to give us the first point, which is actually this point. The next point has to be further away from that point. So I'm going to just assume that we just use Control C, Control V, and use another number slider, Control C, Control V, and add this as maybe between 1 to 10 or 30, because I don't want to give it too much of addition, and name this X2. I'm going to explain that it's going to be X1 plus. That means that it's going to be added to the X1. That's going to be easy. Let's go to the math and use this addition tool. Okay. Bring that forward and add this up. So you can see that I'm going to make an offset here. If you want to give it more offset, you can even add that to what, like 130 and give it more control. So it's based on the way you want to control these points. So we have these 2 points. The next one is to draw a line here or move the points in that direction. Okay. What I want to do is to assume that these 2 points is again, rotate them here in the X direction. So assume that we have them here in the X direction and then rotate that like 45 degrees. So that's not really hard. We just have to copy and paste this, name this as X3 and X4, which is like X3 plus, right? And then rotate these points simply by just using rotate. You can double click and type ROT, find the rotate 3D. I just want to explain this rotate 3D tool, or you can go to transform and use this Euclidean rotate 3D tool to rotate these points. Okay, I'm going to use 2 rotations so we have the structure of these points and use them later. The center is like 0, 0, 0. It's okay. The axis is by default 0, 0, 1, which is great because actually it's going to rotate these points in the Z direction, right? And exactly what we need here. And I'm going to right click on the angle, use a degree, and give that 45 degrees to here. You can also use double click on this connection, bring it down, and then connect it to here. So it's like 2 connection, just like a cleaner result. Get rid of that. Okay, so you can see by changing the number of parts, it's actually moving that, and we can turn off the base points. You just have to select that and middle click and turn off, or right click and preview off. So I turn off the base points. Remember that we had that on the X direction and then we rotated that. So that's also going to help you to completely control these points. So we have here this point, these 2 points, and now we just need to control this one. Okay, so how can we control this? Again, we can assume we have 2 parameters. First of all, it's a degree, maybe alpha. We just want to control that. It has to be between like 45 degrees in our project. And then we have to also define an R or a distance, for example, D, so we can control that also. That's not really hard. Again, I'm going to just copy a construct point, bring it down, turn it on, so you can see it. right? So that is going to be the D. I'm going to name that X5. So that is, let's just make that even bigger so we can control that. Okay. Again, we have to make a rotation. We want to rotate this point. And now the angle has to be something between 0 and 45 degrees. It can't be 0 and it can't be 45 degrees because it's going to not connect the lines. So I'm going to just go to math and use the multiplication. Just a trick here, and use a number slider between 0.1 with 2 decimals to 0.9. We can say rotation for X5. So I'm going to say X5 rotation and give that to the multiplication and then give that to the angle. So this is going to give us also another control between something near this X line and something near the 45 degrees. And that's it. So I'm going to just turn everything off. Perhaps this point is inside this center. I can just extract it, right click on the input and extract it and give it to the center, turn it off. So I can just turn it off. I think that we have everything here. Again, we have this center, so why not just give it here and turn it off? Okay, now we have all the 5 points and we just have to connect the points together and bring the lines. If we want to make this pattern possible, it's not really hard. What we have to do is to define the border, mountain, and value. Okay, for here, what we want to do is to give this as the border. Let me just go to the example file so you can see it easily here. This is going to be the borders because we want to cut it. This is the first border and we have to make it like here. This is the second border. So remember that we have these outer lines as the border. We have these inclined lines as the mountain, and this corner connection and this one as the valley for the crease pattern. Okay, let's just get back to our modeling and we have to remember what's happening here. So let's just play with these points and use that as the base pattern. Okay, remember that this one is going to be the border. So I'm going to just go here in the curve and use this line. We have to connect this one to this one. So these 2 points, it's going to be the start and the end. I'm going to go to the params menu and use a curve container. In the utility, I'm going to just say border so I don't forget that this is for the borders. Okay, that's one of them. Again, we have to connect here. So this connection is going to be here. Remember that this one is like this one, right? And at the end, we have this connection again as the border. So we have 3 connections as the border. I'm going to make another line. This point to this point, give that to the end point, and remember that you have to use the shift key, hit the shift key and then give it to the curve. So we have these 2 in the border, and the last one is this connection. Again, connect this point and this point, use the shift key to add that up. Okay, now we have the base borders here. Let's just put that, align these so it's just easier to understand. Now that we have the borders, I'm going to just group them so it's easier for you if you want to work with the algorithm. The next part is, as you can see here, we have this one and this one as the valley. So I'm going to go back here remember that this one and this one, which is actually going to be this, and this is the valley. So let's just make that this point to this point. Again, you can use a params menu and a curve, put it in a container. So I can Control C, Control V that and name it like valley. You can change the valley and the mountain later, it's not really important, but remember that this one and also this connection, let's make that. This one and this one, use the Shift key to give that as the valley. Okay, so we have this one, and now we have this single line as the mountain, because when we mirror the final result, it's going to give us the second one. So it's not really hard. We just go here, this point to this point. Again, just to make it easier to understand, I'm going to make that as a mountain and make that as a group. And now we have this curve as the mountain. Okay, now that we have them, we have to make a mirror. It's not really hard. We just have to make the plane of the mirror. So you can just type MIR and find the base mirror component, or you can go to the transform menu and find this mirror in the Euclidean. So we have rotate, 3D, and mirror. I'm going to use this mirror tool. And for example, I want to make the mirror of the borders. How can we do that? It's really important. We have to make a plane for this. And by default, it's like YZ, which we don't want. The plane we want to make is a plane with the center here. One of the vectors is going to be in this direction, and one of the vectors is going to be in the Z direction. Let's go to the vector plane, and I'm going to use this construct plane tool to make a plane. So let's just do that. And the center is by default 0, 0, 0. That's okay. The X direction, we can easily make that by a vector. So I'm going to teach you one of the tools which I'm going to use many times in my tutorials, and that is rotate vector, which you can find in the vector menu. Here in the vector, we have rotate. It's actually, let's just talk about this one. For example, I have an X direction vector, okay? And then I'm going to rotate that from the Z direction, right? And that is going to be the actually vector for the plane. So it's not really hard. Let's say we want to rotate the X. Just simply double click and say unit X. The vector we want to rotate. The axis we want to rotate is double click Z, unit Z. And the angle. Again, remember that always in Grasshopper, right click and use the degrees if you want to work with degrees, because it's in radians. And I'm going to give that 45 degrees from here, or I can use this relay connection and give that. Okay, so that is going to be the x-axis. You can see that we have the x-axis, and the z-axis is the second axis is going to be the z. So it's really easy, and that is exactly the plane we want the mirror, right? So that's it. Again, to make it easy, I'm going to go to the params menu and use this plane, and let's just use that. Okay, and again, I'm going to use a curve tool, use this curve and the shift key to add them up to one container. Okay, it's easier to understand, and you can see that again we just need to use this mirror, Control C, or just Control C, Control V the mirror. Again, we want to mirror the valley and use a container to add up the base and the mirror. Again, Control C, Control V. We want to mirror the mountains. And again, a curve container to add this mountain and the mirror with the Shift key. Turn everything off. And we have all the curves we want. We have some duplicates here, maybe. For example, this line and this line is going to be duplicate when we array, but it's not really important because the final plugin we're going to use, which is Crane, is going to understand it's actually one curve. So I'm not going to get rid of the duplicates, but let's just make the final results. You can see the border is okay. We have here the valley and here with the mountains. Now we need a polar array to make the final results. Let's just make that shaded. Okay, and I'm going to go to the transform and use a polar array. That is a great tool. I'm going to use that many times to make symmetrical patterns. For example, this one, okay, the center is going to be 0, 0, 0. It's okay. The count, the angle by default is like 2 pi, which is okay because we want that through 360 degrees. So I'm not going to change that to 360. I'm just going to give that the number of counts. We have that count here. I'm going to just connect it to the count and double click that so it's a relay, and copy this for the other curves. Turn everything off again, and that's all we need. So I'm going to make a group of this, or let's just have this as a group so you can see and move this border here. We have the valleys here and the mountains here again. Let's just delete this. Now, the best part in Grasshopper is that you can control everything, actually all the shapes. You can see that I can control the X1, the addition, the X3, the addition, the number of counts. You can see that's working because I'm going to give that any number from 3 to up, and also like X5, and also a rotation here. That is really great. That is going to control everything. I can select all the number sliders, align them, bring it here and say group, so you can use these number sliders. Okay, so remember that, take these steps to get the final results. And now we have to simulate and actually fold this pattern to get the final results. I'm going to go to Crane. You have to install the Crane plugin. Remember to install it from File, Special folder, and Components folder. I've made a Crane folder here and just copy paste everything there. Remember to right click and go to properties, and if you see an unblock thing here, just click on it so you don't get blocked components. You have to also add some special folders, user object folder, that is in the installation, and again make a Crane folder there and copy paste all the GH users. That is like these yellow components you have, and then restart your Rhino Grasshopper. You will have everything here in the Crane. Crane is really a complete and a good plugin for Grasshopper to simulate origami. But to make it as simple as possible, I've studied this so much. I don't want to get into really too much details. So I'm going to just give you the minimum steps you have to take to get the simulation running. Okay. First of all, you have to find the solver, bring it here to make the solver. And what we need here is just one input, and that is C mesh. Okay, the fold speed is between 0 and 1, so I'm going to say 0.1 to 1 with 2 decimals. You can even give it like 3 with 2 decimals. It's going to make it faster. So remember that. Let's just delete the title and give it to the fold speed. And the rigidity is actually a number slider between like 1 to 20. You can see that input is like an integer, so don't try getting, you can give it a number, but it's going to round it up to a integer. So I'm going to just delete the title. That is actually 2 inputs we need to get running. And now we have the C mesh or the crane mesh, which is really, really simple if you just listen to this step. The first step is like, I'm going to use this C mesh tool. You can see you have 3 options to make the C mesh. C mesh from lines, C mesh from mountain and valley lines, and C mesh from mountain and valley. And I guess that the last one is like triangulated crease line. We don't need that. Let me just explain this too. You can see that you can give it boundary, mountain, valley, and maximum balances, or mesh, mountain, valley. Because we have to, for this one, we have to make a mesh, and we don't want to take the extra step to make the meshes. I'm going to always, actually the like 99% of the time, I'm going to use this C mesh from lines. And you can see if you double click it, it's going to use basically this C mesh from mountain and valley. So we don't, remember that always you have to have this user object folder also copied. So it's going to make it easier to make the final results. Here we go. We have the border. And remember that you have to flatten this, right click and flatten. And if you don't know about Grasshopper, you can check out our second channel, Parametric House, like the Rhino Grasshopper channel, YouTube channel. We have like 3-year, 4-year of lots of videos for Grasshopper beginners, and you can learn about flattened graph, or you can just enroll in our Power course in Parametric House. But for now, we just have to flatten, so all of our output is going to be in one boundary, one valley and one for the mountain. And because we don't have like extra, I'm going to explain that maximum balance in another tutorial, but for now we just want to set that to empty and give that to the C mesh. For the maximum balance, the default is going to be 4, so I'm going to just use a panel, double click and use a 4 here, because it says that it's the maximum number of, let's just explain this, number of faces you're going to use for a mesh. So we have a 3-sided mesh or a 4-sided mesh. Okay, so actually the maximum is like 4, and that is okay. And now we have the final results. Okay, to see the mesh, we just have to turn on the solver, turn on the rigid mode, and turn on the quad flat mode. So remember that always we just want to use this one, these 3 on, and then start it. So if you don't see the results, remember that maybe you just didn't turn on these inputs. I'm going to just push the reset, and we have the C mesh. To see the final mesh, just use this preview C mesh tool if you want to see it. I'm going to give that here. So remember to restart, and if you just fold it, let's just turn everything off. If you reset the result, you can see the patterns. The problem here is that if I change this pattern, you can see it's not changing. So what I actually do is connect this preview C mesh to the base. Okay, restart that. To the base C mesh, not to the solver. Now I can see the changes. Remember that. And remember that sometimes if you just move these too much, the mesh is not going to give you a good result. So remember that this intersection is going to give you, for example, if I run this, it's not going to fault. So remember that you don't have to move that too much to give an intersection. Okay. And now if I just reset and fold it, I can't see it. Again, you have to give it to the folded state. And you can see the final result. So whenever you want to see the folded state, just turn off the crease pattern and you can see the folded state. And now reset, turn off the folded state and turn on the pattern here. Actually, I can use some tools in Grasshopper to bypass this part, but for now it's just easier to use this one. Okay, so again, let's just play with these number sliders. Number of sides. And we will have this new pattern. We want to see how it's going to fold. So I'm going to just turn off. You can click the middle mouse button, turn it off and turn it on here for the folding part. And now let's just go fold it. That's all you want to get. And remember that if you just swap the mountain and valley, for example, I give this to the mountain and give this to the valley and reset that, it's going to fold differently because it's just going to go up and down. It's not going to be different, but remember that you can always swap them. You can see you can get different results. And I have made a layer, for example, border, mountain, valley. And remember that you have to give this color. For example, a border is going to be black, mountain is going to be blue, and the valley is going to be, for example, red. And finally, if I want to make the final results, I'm going to bake that mountain into the mountain, the valley into valley, and the boundary, which is the border. I'm going to make it into border. Now we have it in Rhino. If you want to use it in other softwares, for example, I'm going to use the Origami Simulator. We can just select this and say File, Export Selected. And I'm going to save that as an SVG. So I'm going to say, for example, here SVG and say test. Let's just say like custom 2000 to 2000 pixels. I'm going to go to view and output, put that into a window, go to top and say, for example, if it's a square 2000 to 2000, it's going to be this page. Right click and it's going to give you the output. If you want that thickened line, you can just go to here and go to line type and line widths, and I usually use a 1, 1. I mean, you have to change this default line millimeters here, okay? And now I have this test SVG. Now what I want to do is to show you the simulation in other softwares. For example, Origami Simulator.org. It has lots of patterns you can see. It's really beautiful. For example, I can say like this tower. It has kirigami and origami patterns, even of like a bird here. You can see that. So it's great. I'm going to go to File and Import SVG and select this test and say import. If the file is okay, let's just zoom out. It's going to give you a complete result here. Okay. And now let's just fold that. So you can see that we can get the folding result. That's how you can check that it's the file is working or not. You can see it's like, okay, the folds are working. That's it. In our tutorials, we're going to use the crane plugin, which is really great and fast. But for the future, if we have problem with the crane or the crane plugin doesn't update, maybe we're going to switch to another plugin. But remember, all of them is going to be basically a boundary mountain valley input, and then it's going to fold something. So this is really great. Again, if you want to see a new one, just turn off the simulation and turn on the pattern. Change the inputs. For example, I want to put that to 4 and play with the inputs. And it's amazing. You can just actually produce endless patterns here that you can't even think of, because we made that into a parametric pattern, right? Now again, for example, the X1 is really important because you can move it inside, move it outside. For example, this one, again, I'm going to turn on the simulation and turn off the pattern. Remember that this 3 has to be on, and reset, and then fold it. If I want the mesh, I can bake it and have the mesh in Rhino, which is actually cool. If I want to change the direction of folding, I just have to like change the mountain and valley inputs, bring this down and reset. Again, fold it, it's going to go upwards. So it's really easy and fast. And just bake the mesh. You can see that we have the final results, and it's really great. Again, just for another example, to see the final results. That's it. That's really great. And remember that you can bake these lines into different layers and use that in your project. So that's it. That's how you can make a simulation in Grasshopper. We're going to have more tutorials on patterns in the near future. So remember to subscribe, like this video, and send it to your friends. And also in the comment sections, let me know what you think about this process. I'm going to also explain other patterns. We have Origami patterns, which is like cutting the paper and making like a steps in paper, which is really amazing. I'm excited to share it with you in the near future. So remember to subscribe and like this video. Hope that this was useful. See you in the next video. Bye.